Hi guys, welcome to lesson 24.1 about exponential equations. You will need the lesson 24.1 note sheet, which is posted in Google Classroom. You'll want a pen or a pencil. You also may want your root chart, which is also posted in Google Classroom, and a calculator. Okay, and our learning target today is that we are going to solve exponential equations. So let's get to it. So our key ideas here are that an exponential equation is an equation in which the variable is in the exponent. We know that. Sometimes you can solve an exponential equation by writing both sides of the equation in terms of the same base. So as you can see here, both of these have a base b. So when you get the same base, what happens is you can set the exponents equal to each other. So that's what they did here. They set m equal to n. Okay, so here is your first example, example A, and it's asking you to solve 6 times 4 to the x, which equals 96. So the first thing you have to do is isolate the exponential. So in this case, the exponential is 4 to the x. So what they had to do first was divide by that 6 on both sides. Okay, so when they did that, this canceled, so it was left with 4 to the x on the left side. And then on the right side, 96 divided by 6 is 16. So now you've isolated the exponential. And then what they did here is they rewrote 16 as 4 squared because now these have the same base, 4 and 4. So then you can just take the exponents x and 2 and set them equal to each other, so x equals 2. And that is how you solve for an exponential function. Okay, so if they already have the same base, you just need to take the exponents and set them equal to each other. If they do not have the same base, you need to make them so that they are the same base. And then if they have any, if they are not isolated, you need to do that as well. Okay. Also, this little math tip here says that you can check your work substituting your solution into the original problem and verifying that it's true. So basically, if we plug 2 back in for x in the original problem, it would be 4 squared, which is 16, times 6, which is 96. So yes, that verifies. Okay, so let's try a few examples here together, and then you guys will try 2 on your own. Okay, so this first one here, you have 2 to the 2x equals 2 to the 6th. So right away, because these have the same base, you can go ahead and take those exponents and set them equal to each other. So one of your exponents is 2x and one is 6. So you set those equal to each other, and then you're solving for x just like we would in like a linear equation. So I would divide by 2 here, and x equals 3. And that's it. That's your answer. Again, you could plug back in to check. So if I plug in 3 for x, that would be 2 times 3, so 6. So it would be 2 to the 6th equals 2 to the 6th. And yes, that is true. Okay. All right, awesome. Then let's try out this next one. So remember, your first step should always be to isolate the exponential. So this 3 to the x is our exponential, but we have that minus 1. So what we need to do first is add that 1 over. So that's going to leave us with 3 to the x equals 81. Now, these are not the same base at all. So what I would do here is take a look. If you can't see it already, I would take a look at your root chart and see, okay, can I get 3 to somehow have the same, can I get 81 to somehow have the same base as 3? So then what you could do is look at this row here for number 3, and you see 3 squared is 9, 3 cubed is 27, and 3 to the 4th is 81. So writing 3 to the 4th is equivalent to saying 81. So if I go ahead back here, I can say instead of 81, I'm going to write that as 3 to the 4th. And remember, those are equivalent, so we're okay. So now we have 3 to the x equals 3 to the 4th. And our bases are the same, so all we have to do is set these exponents equal to each other and solve for x. So x equals 4, that one solves itself. You don't need to do anything else. X equals 4. Okay. All right, then let's take a look at this next one. You have 2 to the x equals 1 over 32. Okay, so again, these do not have the same base, but if we go look at our root chart, 2, so can we get it to have the same base of 2? So you have 4, 8, 16, 32. So 2 to the 5th does equal 32. However, we have a fraction here. It's 1 over 32. So kind of what you can think of this is like 1 over 2 to the 5th. Or all you have to do is remember that when it's a fraction, you need to use the negative exponent. So this would be like 2 to the x equals 2 to the negative 5th. And if you plug that into your calculator, you will see that 2 to the negative 5th will give you 1 over 32. Okay? So maybe jot yourself a little note that 2 to the 5th equals 32, but 2 to the negative 5th power equals 1 over 32. So it just makes it into a fraction. Okay? And that's important to know. But now we have the same base, 2 and 2. So all you have to do is set these equal to each other, the exponents, and you should be getting x equals negative 5. And that one kind of solved itself as well. Okay, then we keep moving here. This next one, we have 4 to the x equals 2 to the x minus 3. Now, in this case, you hopefully know that 4 and 2 are not the same base, but we can easily write 4 as 2 squared. Now, here's the thing. We have 2 squared, but then there's another x there. So what I like to do is also put little parentheses here and then include that x, okay? And then we have that equal to 2 to the x minus 3, okay? So now what we need to do is we do have the same base, 2 and 2, but we need to set these equal to each other. So when you have a 2 on the inside and an x on the outside, you have to remember your exponential rules, which is that we multiply those. So 2 times x is 2x. And then we set that equal to the x minus 3. Okay. Now here again, just like the first one, we do actually need to do some solving. So I would subtract over the x. And then that's going to be left with x equals negative 3. Okay. All right, awesome job there. And then this last one, we have 6 to the 3x minus 4 and 36 to the x plus 1. So again, if you do not see right away how to get these to have the same base, use your chart, your root chart. Okay, so how can we get 6 and 36? Well, 6 squared is equal to 36, so that's what we're going to use. So we would rewrite this as 6 to the 3x minus 4, we're not going to change that one, equals, but now we need to change this 36 to be a 6 squared. Okay, so I'm going to write that as 6 squared, and again, I'm going to do my parentheses, and then we have the x plus 1. Okay, so now, again, we have the same base, both of them are 6, but then we need to set these exponents equal to each other. So this is going to look like 3x minus 4 equals, don't forget about this 2 here, so that's going to be 2, and then remember, just like the last one, you have to multiply it, but this time by x plus 1. So in the last one, we just did 2 times x, but now it's 2 times x plus 1. So we're actually going to have to distribute that. So 2 times x is 2x, and 2 times 1 is 2. So now we have something linear here that we need to solve for. So I would subtract the 2x over. Whoops. and be left with x minus 4 equals 2. And then I would add this 4 over, because remember, we're solving for x. We want to get it by itself. And I would be left with 2 plus 4 is 6. So x equals 6. Okay, so those are all just a little bit different types there. The first one, we had the same base. The second one, we had to isolate and then get the same base. The third one, we had a fraction, so we had a negative exponent. The fourth one, part D, you had to multiply your exponents, and then same thing with the last one, you had to multiply and actually distribute your exponents. Okay, so all just a little bit different. So now what I would like you guys to do is go ahead and try these next two. So you have 5 to the x plus 1 equals 25, and 2 to the 10x equals 32. So pause the video here and try that. And then hopefully you paused, and now go ahead and check your work. So for the first one, you had 5 to the x plus 1 equals 25. So 25 you should have rewritten as 5 squared. Then they have the same base, so you set x plus 1 equal to 2, the exponents, and you solve for x to get x. Oh, that's wrong. That should be x equals 1. I added instead of subtracted. So 2 minus 1 equals 1. And then this next one here, 2 to the 10x equals 32. So to get the same base, we know that 32 we can write as 2 to the 5th. So then you have 2 to the 10x equals 2 to the 5th. You have the same base, so set those exponents equal to each other. 10x equals 5. Divide by 10 on both sides to get x by itself, and simplify, and you get x equals 1/2. Okay, and again, any one of these you can check by plugging your x value back in and making sure it makes the equation true. Okay. All right, any questions? Feel free to leave them here or bring them to class tomorrow. And that's it for today. Have a good one. Bye-bye.